impossible connections, perspective shifts, eternal brain scratchers, these are the inherent qualities of any Monument Valley level. For just over a year, I was lucky enough to work on the most recent game in the series, Monument Valley 3. I was able to contribute levels alongside the wonderful artists, programmers, designers, QA folks and audio magicians at Us2Games. What I'd like to do today is to show the process of getting a level ready from the idea in your head through to sketching it out and making it in Engine. The Monument Valley series has some of the most beautiful and vibrant puzzles ever committed to our medium. The core premise is an exploration of impossible geometry along the lines of the Penrose Triangle or the work of Dutch graphic artist MC Escher. The objective is to get your controllable characters to either a door or plinth that will end the level. Part of the challenge is being able to perceive the way forward for your character through the environment. This might mean moving a platform so that it becomes a traversable Penrose Triangle, or rotating the entire level to see it from a different perspective, thus lining up platforms. So there's lots of ways to start making a Monument Valley level. You can jump straight in the engine and use the in-house tools to start making cool impossible shapes. You can sketch your ideas out and plan obsessively. What we'll do here is try to take as comprehensive a look as we can into the details of each part on the way to making a very simple level. For me, I love to start by getting as much context about what the level needs to do as possible, whether that's from a narrative or difficulty perspective, or the mechanics that should be prioritised. Sometimes there isn't a narrative thread to lean on, so I'll often create a kind of timeline of events to give the solving of the puzzle some sort of direction and purpose. Sometimes that narrative beat can be as simple as the player is ascending a tower to save its resident keeper. From there, you at least have some directionality to the flow of the level. That brief can be more exploratory, like you want to see how a puzzle can use three sides of the same platform, using that impossibility for the player to traverse across them. This context or brief is similar to just having a cool idea that you want to bring to light. It's something that should inspire you to see it brought to life. At the next point, you might move straight on to implementing that idea in Engine. For me, I need to explore it visually through pen and paper or on a paper prototype. This is just me needing to exhaustively structure things. When it comes to sketching out Monument Valley levels, the isometric perspective is important to get right visually, since that's where a lot of the impossibility happens. One way to practice that type of sketching is to open up an existing Monument Valley level you like and start to get the basic structure of the levels copied onto a page. I start with the edge of a platform and get the vertical lines of its edge down. Then you have these diagonal lines join them to make a platform face. As long as you keep those diagonal lines roughly parallel, you should end up with an isometric draft of the level. Back to our level sketch though, what I want to explore in this example level is a simple way to show impossibility. A good way of doing that is to have a platform move in front of and in behind the same piece of geometry. I'll show that with two sketches here. We'll have this core one piece of level geometry that extends out into the foreground in the lower half. What we'll do with this moving platform is have it appear in front of the lower half, and when it moves up vertically, it will go in behind the top half of the geometry. With these concaves in the lower half, we should be able to have the player traverse across the sides of the geometry using the moving platform. We can place either a door or NPC that they have to get to as part of the puzzle. With your plan all set out, it's now time to get an engine. The programming team at Us2Games have a truly robust and beautiful set of design tools to make levels in. As with any toolset, once you're familiar with the basics and have practiced setting up levels, it doesn't take too long to get a white box of a level made. At the core of these tools are the geo objects which function as platforms. As soon as you have a geo object in the level, you can use the geo editing tools to switch whether you are selecting the whole geo itself, a block, or just one face of one block. From here we can select a face and extend out more blocks to the core geo object and make our basic shape. If we want more complex shapes, we can right click to open a menu and instantiate, say, a concave. That will help us make that shape extend into the foreground and allow the player to walk from one side of the geo to another. To make our moving platform, we'll create a different geo object. I'll extend it to the height it needs to be. I want it to be a dragger, so I'll search in the project for the little dragger nubbins and drag them onto the geo object in the hierarchy. This object has all the touch functionality we need for the player to be able to interact with the platform. Next, we need to add a mover component to the inspector of the geo object. We select the type of mover that it is, whether it's a dragger or a rotator. Then we pick the axis of movement for the dragger. Finally, we just need to set its movement limitations. One thing that's important about the Geo platforms are these little nodes on top. These are the nav objects that allow our characters to walk on the platforms from block to block. We can select individual faces and toggle the nav on and off. We're going to need to do that for the sides of the platform if we want the player to solve the puzzle across the whole thing. So we have the core geometry in place and a functioning platform, but if we hit play and try out the level, the moving platform doesn't move in front of and behind the geometry like we want. So we've built one continuous piece of geometry that exists as you might expect it to in the real world, but in Monument Valley we need things to surprise and delight the player. To do this, we're going to need to split our single piece of geo in half. We'll then move this top part forward in perspective in the scene, and the bottom part backward in perspective in the scene. We'll keep the moving platform in between these two pieces so we can get the effect to work. Okay, when we try that, the effect works, so now we just need to do a couple more things. One thing we need to do is make sure the player has something to aim for, whether it's a door or an NPC they really want to talk to. For now, I'll place the objective here and try the level to see how it goes. So we took a little level concept from brief to white box pretty quickly, and that's how fast you can get a level up and running for a Monument Valley game. There's loads of different types of experiences in a Monument Valley game, from gentle tutorials to mind-bending puzzles, from full-level rotators to small geo toys. I've been lucky enough to chat with some of my former colleagues to see what some of their favourite level types are, and what the most challenging thing is about making them.
My favourite levels in MV are often very, very simple. I think one of my favourite ones is the bar house one. Yeah. And at the very top you've got the yellow sort of circle of the sun. And this very, very simple puzzle of it's just two moving parts.
Yeah.
And I'm just fascinated by how simple it is.
Yeah.
But it's like, it takes about 4 moves, I think, with just these 2 moving parts to get yourself across here. And at first it seems impossible. Yeah. I think that's one of my favorites, those ones that just, they boil it down perfectly somehow.
I think I like the levels either they give me a wow moment because it's not about the puzzle itself, but more about the scene. It reveals really cool. I think those are like the box level in the first Monument Valley. The puzzle is not very difficult, but it's just cool. All the things moving around, how it unfolds. That's one type. The other type is also more like if the puzzle can give me an aha moment. Maybe sometimes it help me to think more outside of the box to change the way how I think about how certain things can be used. I think some example maybe the totem level. Also in MV1. So I remember there's one level you need to light the totem down horizontally and use it as a bridge.
When you initially asked me that question, I thought I was going to answer something completely different. Like, I used to really like the totem levels, but then I thought about it harder and I was like, actually, I think the levels I like are just the ones that make you think something's going to happen and then something completely different happens, like a twist or a break of the reality of what you'd normally expect. I think my favourite level is Chapter 7 of Monument Valley 2, the Brutalist architecture one, the towers, where you kind of face on, you're in the isometric perspective for a lot of it, and then suddenly it shifts and you're face on and you're in this 2D flat world and you just didn't expect it to happen at all.
Yeah.
I absolutely love that level. I remember talking about it a lot, like throughout development of MV3. It's just like, oh, I really love how this level just completely twists what you expected to happen.
I think there are a lot of challenges. One thing might be like, it's hard to make something that can make everybody enjoy because people have different levels of skills on solving puzzles. Some people are just better at it, some people are less better at it, but you want most people, all of them can still enjoy it. So that means sometimes you can't make it too difficult, but still, they don't want to make it too difficult. You also make sure people who are like really good at solving puzzle can also feel satisfied by playing it. So that means it might not be very difficult, but it still need to be cool like us.
Yeah.
And I think that's tricky to balance difficulty to make it.
There's a lot of different things, but I think the one that's the hardest is that you can't just design with logic, because whenever you start to actually physically make it, it never works out exactly how you thought it would in your head. And then you have to kind of rearrange things, and because parts of puzzles are very specific in the way that they are laid out, like it has to work step by step, when you suddenly have to shift everything 2 cubes to the right, the whole puzzle breaks. You have to remake a whole part of it, and it's definitely one of the most trickiest things I found, because I like to do a lot of things on paper before I make them physically or like in Engine. So trying to get over that hurdle of like, I can't just work out the logic of what this puzzle is going to be before I make it, was quite hard. I don't know if you had a similar like...
All the time. I
Yeah.
constantly sketching and making notes, and I will try to like, okay, if I draw this out and then I try to make it, like, oh, but it doesn't work because it's impossible. And the amount of times
Oh
I get
right, I
caught by that.
can't draw something that literally doesn't exist.
I think often you have an idea in your head, and making that possible is usually the biggest challenge. So you have like, I'm sure I could do this thing.
Yeah.
I'm sure it'll work. And then you do it and you're like, wait, that's not it. Or, oh no, that's not quite what I was thinking. Or you've made it and actually it's not as cool as you thought it was going to be. It was just in your head it was cool.
Yeah.
I found that often I did sketch things on paper, but I don't think I had the same approach as you, where you meticulously planned out on paper and really understood it and then went into it. Whereas I would go into Engine, I would play.
Yeah.
And I'd play with like, okay, I'll just put a door somewhere. That's where I'm going to get to.
Yeah.
And play around with like movement and shapes and transitions to try and find something. So I
Yeah.
was more like a play and explore to discover.
What I want to do now is take you through the design process for one of the levels in Monument Valley 3 from start to finish. I think it's useful to see each stage of this process and show how different decisions could have ended up with a wildly different level. So we'll look at the last level in Sub Rosa, the final chapter. This level is in 3 phases, where the core interactable at the centre is changing its form throughout the puzzle. During each phase, the player must step on these buttons to turn on lights. The brief for this level was to essentially make the final level, something that felt grand in scope and difficult, something to cap the experience of the game. It needed to fit within the mechanical expectations set by preceding levels, which centred around moving splines. After playing and analysing the final levels of the first 2 games, I started to think about the narrative up until this point and what this final chapter represented. There are analogies in the 3rd game about community resilience in the face of climate change and how we move away from unsustainable fuel sources. When thinking about how the narrative unfolded and mechanically what the chapter was doing, there was a prototype level another designer had made which sprung to mind. This is Shu's Mobius level. The Mobius can be rotated so that it's opened and closed. When closed, it forms an infinite loop where the player can walk to any part of it. It's comprised of 3 curved splines in a trench coat that are joined in a specific way and then rotated around a central point on the x-axis.
Yeah, that was a cool one, because that is really thanks to Matt's original design of that shape. It was early stage. We have early pre-production. We had every Thursday we do this play make time, and that time the theme was called Infinite Runner, and Matt just made that shape. And that really blew my mind. I was like, what is that? It's so cool. Because I was trying to make something look like, but I just cannot figure out the math. And Matt just made it. And eventually, after maybe a few months, we were trying to do some spline chunks. And I thought, I'm going to do a puzzle with that one. And it was, I think, because it was the coolest thing about it is the rotation, right? When you rotate it, it transforms between the open spline and the Mobius. So I just added a rotator to let the player rotate And because you can work, the cool thing about Mobius is like you can work all the faces. You can work to all the faces. Everything is connected. It's infinite. And just made the puzzle based on that. Player just always need to make it Mobius, go to another face, and then open it, and then it will take them to different places in the scene.
I loved this prototype, and I thought that its mechanical representation of the infinite was perfect for what the narrative was trying to get at. With curved splines becoming more prevalent in the final chapters, it signals a shift towards the infinite, which the player finally encounters in this Mobius form. I felt like anything we do for the final level should use this Mobius prototype in some way, so I started to explore how we might signify that transition from the impossibility of Monument Valley geometry to a kind of infinity-based geometry for the final level. On researching this infinity geometry, I was excited at the prospect of making Celtic knots. I tried a few types of Celtic knot levels, but they always looked a bit strange or we couldn't get them to work right. Instead of focusing more time on experiments that weren't quite working, it was better to embrace the infinity of the Mobius prototype as the final phase of the level. So from these Celtic knot experiments, I started to look at the idea of the level becoming a transition point from impossibility to infinity. For this I needed a strong piece of impossible geometry to situate a classic puzzle. Part of that work is looking through impossible artworks. I kept coming back to this inverted cube thing. It was actually the broad shape of the final puzzle in the first game. What I had decided was to hollow out the centre of the cube and use moving geo as the centre piece that the player interacts with. Playing with this hexagonal frame, there was one thing that became apparent. There is an inside face and an outside face that is difficult to traverse. But to have any possibility of a functional puzzle, the player needs to be able to move between these dimensions. Using the interactable geo, I made a few iterations of platforms that could potentially achieve this. The idea of geo that would move in such a way as to occupy both the inside and outside faces of the frame felt nicely impossible to me. And this centre iteration felt like it had the strongest puzzle possibilities, but I couldn't quite solve the issue of these two intersecting splines and the player not being able to travel across them in some way. From this point, I wasn't quite sure where to go with it, but luckily I had expert advice from the game's lead designer.
There was a point in the creation of that where I was stuck and there were lots of different versions of that level, and I think I will always kind of treasure your feedback and the kind of conversation that we had that felt so simple and so like, oh, of course that's the answer, but I couldn't have gotten to that point without the kind of that conversation, is your kind of advice to simplify it in some way. How did you have that lens to be able to look at that and kind of break that down and say, no, this needs to be simple? Like, can you remember anything from that part of that kind of process?
I do remember it because it's really special for me as well.
Really?
I helped. I think this kind of links to being a lead a little bit. Like I have a distance from what's actually being made.
Yeah.
And every designer is on their journey of making something that they have in their head and trying to make it real.
Yeah.
And most of the time I can't help because I can't quite see, like, you know, when you have the idea and you've drawn me something and stuck bits of string to it, I'm like, okay, Ryan, if you say so, just have a go and then show me. All I can do is be a good reflection tool.
Yeah.
I think I've learned over the years that even for me, I sometimes add too many limitations and then I end up stuck, and I'll come to someone, I go, look, I want to do this thing and it needs to do this and I want it to do this as well, but it can't do this and it has to do this as well. And I end up with too many limitations, and then the person I'm talking to kind of looks at me and goes, well, which one don't we need?
Yeah.
Like, you've got too many things that can't be all these things.
Yeah.
And I think over the course of Monument Valley, I learned, how can I be useful to my designers, the designers I'm working with, if I don't fully understand what their vision is,
Yeah.
but, I have to support you in achieving what you want. So I go back to basics of like, okay, well, can it be simpler? And I think I remember seeing in that you actually described it to me. You described what it was doing, how it was doing it, and its limitations.
Yeah.
And I think it had like these. I talk about it when I do presentations and stuff, because
Right.
your first version of that puzzle, it had a really satisfying movement to it.
Yeah. Yeah.
And so when you dragged those draggers, it just moved in this so satisfying way.
Yeah.
But it didn't leave any space for the player.
Yeah.
And I think that was what led me. It's like, oh, this is really cool as a moving object.
Yeah.
But there isn't actually physical space for the player.
Yeah.
And I think that sort of led me to like, oh, well, maybe if we take an arm away,
Yeah.
you get something. But then you saw the potential for the puzzle. I didn't see that. I saw that like, maybe if we make it simpler, and then you're like, oh yeah, and you because you really understood the puzzle you were making,
Yeah.
you could see the like knock-on effects of that
Yeah.
of that change. Yeah.
This advice from Emily came at the perfect time. From then on, I could see a path forward to making this a cool puzzle. With having just one of these splines in the centre, we needed a way that the player could travel to each of the 6 faces. In addition to the dragger that inverted the spline, I added a rotator that the player could move from one side to another. This opened up each face of the puzzle. From here, I could take a look at the steps of interaction it would take for players to navigate around the hex and place objective buttons appropriately. It's worth zooming in on the intricacies of how this spline even works, because it took a lot of time and iteration to make it feel right and impossible. It's actually 3 different geo objects that are at different levels of perspective to retain that impossibility. To facilitate movement between the inside and outside faces, one of the splines needs to be constantly below the hex frame and the other has to be over the geo. Because rotation mover components only move in one axis, each of these objects had nested movers to ensure that they moved where needed. To make sure I could keep track of all these nested movers, I made sure to have a somewhat understandable naming convention in the scene hierarchy. If we open up one of these spline objects, you have the spline at its base. This one is referred to as L1 because it's the spline that is lower or behind the hex frame in perspective. The 2 next parents have a D to designate that it is activated by the dragger on the Y and Z axis. The final parent has R to designate it as activated by the rotator and a Y for the axis it is moved on. To make the movement of these 2 curved splines appear as one, the movement was synced around this one block of geo in the centre. This made it much easier to organise multiple nested movers on different objects, as there was always this core reference point. With this puzzle feeling complete, we knew that it would transition to the Mobius form in some way, but this level also comes after another puzzle which explores spline movement. To make this level feel like the finale of the chapter, let alone the entire game, we needed to incorporate the lessons and mechanics from previous levels that the player has encountered so that the chapter has a nice flow to it. One of the cool things the previous level by Marie did was the movement and twisting of spline ends. Each spline is made up of 2 end knots which can be moved and rotated. Cool puzzles can be made when you rotate one of these end knots by 90 degrees, as it allows players to reach different sides of the same platform. To make a cleaner transition between these 2 levels, I made another phase to the final level. It still uses the same hex frame, but it leaned further on that idea of impossibility to infinity that I had been chasing. With this phase, I wanted to initially show that classic form of impossibility, then incorporate a shade of the infinite through the twisty end knot. What we found when playtesting this phase initially was that we needed to eliminate a part of the hex frame to make sure players weren't as confused when playing. The phase led to some backtracking and players getting lost, so this section here was eliminated from the hex frame and we added it back during the transition between phase 1 and 2. One of the things I had to do for the whole level to take shape was analyse the final Mobius phase. There was a world where I wanted to explore if we could do a multi-stable Mobius phase, which is basically the upside down MV levels, but that would have been way too much for the level. With that said, even analysing the Mobius form provided insights into possible platforms and how to reconstruct the puzzle for the start and end of the phase. With the rotator for the Mobius, there are 4 resting points. With these resting points, there are 6 main points of player traversal to external platforms. with the main conceit of the puzzle being the opening and closing of the Mobius, allowing the player to walk to any point of it. The player has to figure out which point of the Mobius to walk to so they can get to the right platform. Just because there are 6 possible platforms doesn't mean we need to use all of them. We don't want the puzzle to overstay its welcome, so we need to find the right combination of platforms. What is important is that to get to some of the platforms, the player needs to stand on specific points of the Mobius for when it comes apart. What I did was labelled each platform side with a letter and the corresponding part on the Mobius that the player would need to stand on. From this we can see that some platforms would require the player to stand on a part of the Mobius that they couldn't see, which is something you don't want to ask a player to do. So we narrowed the platforms to correspond to these matching pairs where the player's path forward is on screen when the Mobius is closed. Something that Shu found in her original puzzle was that it was difficult for the player to keep track of where they would need to stand when unravelling the Mobius to get to the platforms.
I think when we tested the first version of it, the problem is it was cool, but the player cannot remember which face connected with which island. And the first thing we tried is adding color to different faces, but then it breaks the art a little bit, and then we end up with the patterns eventually to give something more gentle, and but still give a hint. But there are players complain about the hint we gave though. I saw some comments, I think somewhere, like, oh, why do they give us the hint we want? But yeah, that's the problem. Like I was talking, some people want something more difficult, some people don't want things to be that difficult.
The entire way through this process, each week colleagues at us2 are playtesting the level and giving feedback for what they liked or disliked about it. There's constant iteration going on and discussions about player flow through the level and the entire chapter, and this is where some of the best points and work comes from, in showing off your work to others and them contributing vital feedback. Okay, after the puzzle works and gets feedback to iterate on, it moves on to be made beautiful by the art team. However, throughout this period there are also bugs to fix right up until launch, and oh my, there were some crunchy bugs in this level. There was this persistent problem with the puzzle, the fix for which I called my anti-squish logic. The problem was that if you moved the player character to a particular part of the hexagonal frame, you could move the central spline in such a way that it would cover or squish them, potentially confusing the player. This is something we definitely didn't want in the finished game, so my fix was to detect at any point if the player character was standing in these areas and moving the splines. This would cause the character to move to a designated safe zone. What this requires is setting up objects in the scene with character volume sensors, which is just a little collider box that detects if a specific character is overlapping with it. There are then other sensors which detect if the dragger or rotator goes over or under a certain value. All of these sensors are placed in yet another object with a trigger component which detects if all of these things are true. It then points to the visual coding section of Unity, where we determine events and cutscenes in the game. Now if you're a programmer, look away now, but this is what the logic looks like. These nodes are taking in information from the sensors and triggers described above to tell the character to move elsewhere. How does the system know where the player should move? There's another object, of course. It has a smart location component which the player can use to navigate across the nav objects. For the areas that are now covered by the central spline, we also need to turn off the nav on that geoface so that the player can't walk inside the spline. So what this also means for some of the logic is we need to add a frame delay to the nav turning off so that the player has enough time to move from one nav to another. Otherwise, if the player really wanted to, they can move the dragger really fast so that the nav turns off before the player character could walk to safety, thereby stranding them. By all means, this is definitely not the best fix for the problem. It's papering over the cracks in a convoluted way, but it's one of those acceptable fixes for an outcome that most players won't experience. Usually, when the player walks on a piece of geometry that is controlled by a rotator, that rotator locks, constraining the solving of the puzzle. There was a bug where the automatic locking of the rotator wasn't working on spline geometry, so I had to go in and manually place character volume sensors everywhere that the player could possibly be whilst they are on the central geo in Phase 2. I had to be careful with where I put these sensors because they might overlap with the areas the player can stand on within that hex frame. So there was lots of back and forth testing to make sure that the size and placement of the volume sensors was correct. And if I was fixing another bug where I moved the location of the hex frames in or out of perspective, I had to be careful that I didn't break the fix for the rotator lock. There were lots of other bugs to fix, but there was one bug in particular that brought shame upon my house, for it was still in the game at launch. I'll not show this bug, but I will discuss the interesting production issues that came with fixing it. The bug arose because of the very nature of the impossible geometry, because the geometry is both above and below the hex frame. When we discovered this bug, it was maybe a month and a half out from launch. I brainstormed a couple of different ways that the bug could be fixed, but they would be time intensive and there was no guarantee that the fix would work. I got on a call with experts from design, art and programming to take a look at the bug, what was causing it, and if there were any possible fixes that somebody from a particular department could make. On the table for options, there was my own risky fix and another more radical approach to rebuild the level from the ground up, which would definitely take care of it. We talked about both approaches in depth, but we also had to consider the severity of the bug and whether it warranted such action. Was it really so bad? How many players might even see it? Was the fix worth the time when that effort could go to other parts of the game which also needed work given how close the game was to launching? Ultimately, the time we could have spent fixing the bug was spent elsewhere, and I think that was the right call. It's the inevitable problem with all game projects. There will never be enough time and resources to fix everything that needs attended to. So one of the most important parts of development is putting our production hats on and deciding which things need that attention. With this video series, I want to give people an accessible way to get into game design, whether it's with pen and paper or freely available tools. But there's so much you can learn from designing game experiences, even if you don't have access to the tools. It's nice to imagine a world where everyone can make Monument Valley levels so they can showcase what their take on impossibility would be. In this lovely imaginary world, I asked my former colleagues what advice they would give to those starting out on their adventure making levels for a Monument Valley game.
When I was building up my own skills, it was make an existing level, figure out, see the image of it and go, okay, I'm going to make that one, play it, and then go make your own version of it. Because then you'll be like, oh, okay, they hit, you'll find a problem. It's like, oh, how did they do this aspect? And you'll have to figure out how did they hide the impossibility, and you'll learn a lot from doing that. Find cool impossible shapes and make them. But when you've made them, make them move in interesting ways.
Yeah.
Or move parts of them so that at the beginning it's not impossible, but at the end it is. And find those limitations of that shape.
Probably that your puzzle is already really hard. You just don't realize it. You've looked at that for, I don't know what, 10 hours already. You know how it works. Someone else doesn't know how that works. You need to go and make them play it. And then the other thing is it's kind of a less is more situation in Monument Valley. Sometimes the more you add, the less satisfying it is. Whereas the more you take away, the more satisfying that one moment is. So it's like a case of you don't always need to add more things to the level to actually make it more interesting. Sometimes actually removing a thing is better in this case, in this scenario, because you get a more satisfying puzzle. It's like clicking two shapes into each other. When you do that, it feels really nice. But the more of that you add, the less it feels good.
I think maybe it's better just go broad, go brave, try different things. If something just try many things. And if we try something, it didn't work, just throw it away and start again. So I guess normally maybe you try 10 things and maybe just one of them work. And it's a fact. It's not like you are bad at it or something. It's try something that feels, it could be something that feels very different, very unique. It maybe feels a bit crazy at the beginning when you try something like that, but don't put too much restrictions on yourself, at the beginning.
Some top level wisdom that Flo delivered upon me. They were playing one of my levels, and the way they framed it as well was perfect. It was you're showing the key before you show the lock, and I was like, oh, you're showing the button before you're showing the problem of why you need the button. So bring that earlier.
I feel like the strength of Monument Valley game is that many different people made the levels.
Yeah.
And each of those people had a different approach.
Right, okay.
And each of them had a different possibility space in their heads.
Mm-hmm.
So the ideas you came up with were very different from Shu, were
Yeah.
very different from GV, from
Yeah.
Matt, from anyone on the team. And
Yeah.
so the game is what it is because
Mm.
everyone could see a possibility that was different.
Yeah.
And so anyone who approaches making a Monument Valley level, they have a unique possibility space in their head.
Yeah.
And I guess maybe the advice is to follow that. Like maybe only you can see it. You might describe it to someone else, you might explain it, you might draw it.
Yeah.
But until you've made it, no one will really get it.
Yeah.
Hopefully this has given you a small insight into the process of designing a Monument Valley level. I hope in whatever capacity it gives you the confidence that you could sketch out and make your own impossible level. If you've been enjoying the most recent game in the series, let me know down in the comments. So much love went into it from every department, and I'm sure each of them would love to know what your favourite moment was. The joy I got working on a Monument Valley game was only matched by the wonderful people who I got to work with. I hope you find joy in whatever game design practice you're doing next. Thanks for watching. If you'd like to learn how to design more games and puzzles, then consider subscribing. Until next time, take care.